Welcome everyone. This is the second of 3 videos in which I describe the steps required to prepare and purify an organic liquid. In the first video, I described the process of reflux used to prepare a sample of ethyl ethanoate. Check out the link in the description to find out more about this stage of the synthesis. In this video, I'll show you the balanced equation for the synthesis and identify unwanted compounds that could be present at the end of stage 1. I will also explain how unwanted products can be removed with a separating funnel. I will refer to the procedures given in the AQA A-level chemistry required practical handbook. The content of this video is relevant to all A-level chemistry students as well as BTEC Level 3 applied science students. Let's get started. This is the procedure for stage 1 which I looked at in the previous video. Please note that any practical work must be carried out under the supervision of persons qualified to do so after completing a risk assessment. The reaction carried out was an esterification. An alcohol and a carboxylic acid reacted in the presence of an acid catalyst to produce an ester and water. This is a reaction that you should familiarise yourself with. In this reaction, ethanol reacted with ethanoic acid. Acetic acid is another name for ethanoic acid, but you should really refer to this substance as ethanoic acid. This is the IUPAC name. Anhydrous ethanoic acid, that is ethanoic acid that is free from water, is referred to as glacial ethanoic acid. The ester produced in this reaction is ethyl ethanoate. In the photograph, reflux apparatus is shown on the right. Following the reflux, when the pear-shaped flask is cool enough, the reaction mixture is poured into the separating funnel. The tap on the separating funnel must be closed and try to ensure that anti-bumping granules remain in the pear-shaped flask. A separating funnel is used to separate 2 liquids that are immiscible, that is, they don't dissolve in each other. Polar substances, ethanol, ethanoic acid and sulfuric acid in this case, dissolve in water. Non-polar substances, ethyl ethanoate, do not. We often use the phrase like dissolves like. This means that polar substances dissolve in polar solvents. Adding sodium carbonate solution to the separating funnel will cause fizzing if there is any acid present. To ensure that all of the carbonate reacts, a stopper is inserted into the separating funnel. The separating funnel is then inverted several times. Hold the separating funnel upside down and open the tap when it is pointing away from yourself. This allows gases to escape before the pressure builds up too much. The aqueous layer can be separated using the tap. Further portions of sodium carbonate solution can be added. When there is no more fizzing, all of the acid has been removed. A diagram of the apparatus is shown on the left with a photograph on the right. If you look closely at the photograph, you should be able to make out the boundary between the 2 layers. You might also see bubbles in the upper layer. These are carbon dioxide gas. This is produced when carbonate ions from the aqueous sodium carbonate react with any acid that remains at the end of the reflux, sulfuric acid in this case. Sodium ions and sulfate ions also dissolve in the aqueous layer along with any unreacted ethanol and ethanoic acid. The aqueous layer is removed using the tap. If you look at the top layer in this photograph, you might notice that it is hazy. This indicates that there is some water present alongside the ethyl ethanoate. A drying agent can be used to remove the unwanted water. Anhydrous salts such as calcium chloride or sodium sulfate can be used as a drying agent. The ethyl ethanoate drains from the separating funnel into a beaker and a spatula of the solid drying agent is added. Water molecules hydrate the salt and remain trapped in the solid. All of the water has been removed when the drying agent no longer clumps and the liquid appears clear rather than hazy. The ethyl ethanoate is decanted into a clean pear-shaped flask to be distilled later. This is the first part of the procedure for stage 2 that we have looked at in this video. Please note that any practical work must only be carried out under the supervision of persons qualified to do so after completing a risk assessment. I won't read each line, you can pause the video if you want to do this. And here's the second part of the procedure for stage 2 involving the drying agent. In the next video, we'll look at the process of distillation used to purify the product. Thanks for watching. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.